what's going to happen is we're going to rough this out with a 1/4 inch end mill, but these corner radiuses have to come down to 62 thousandths with the 1/8 inch end mill. So if I change this end mill's definition, let's say I put the shank like we didn't grind it at 125 thousandths. Now the tip of this is probably going to be around 123, 124, the actual ground diameter of the end mill. These cuts are going to be done with cutter compensation, so it really doesn't matter what I put in the CAM software here because I'm going to control it at the machine as far as the size. But let me just simulate this and you'll see what will happen, because I'm using a short cut length end mill on purpose because I need the rigidity and stiffness of this tool, but this 3/8 of an inch cut depth can't make it down to the bottom of this pocket here to up here, which is the highest corner of this thing, is around 630 thousandths. So let's simulate this cut with the end mill shank unground and we'll see what happens. Okay, I gotta reposition it here because the part rotates the C-axis. And see how it collides with the shank of the tool? So I have to relieve the shank, obviously, to get down to this depth, which I'm going down to the end of this 20 thousandths radius that's in the bottom here. And then I'm going to come back with another 1/8 inch end mill and finish that and the corners. This is just a roughing tool. And usually and these little passes are like 10 thousandths of an inch per pass going downward. This is the best way I've found to rough out these corners in this, what's going to be this titanium material. This has worked in the past for me. So let's stop the simulation and let's go back and we'll redefine this tool. We'll go, say we'll grind the shank to 110 thousandths up above the cut length. And now we'll resimulate it, and you'll see it'll make it all the way down to the bottom of the pocket this way. So I do this quite often with the grinder, and like I say, I'm going to come back and take this radius down to the bottom of the pocket with another 1/8 inch end mill that has a 20 thousandths tip radius on it. This is just to rough out the major part of the material with this tool. So that's what let me show you what the actual end result's going to be here of the, if I unselect this, I can show you. And this is what the pocket's going to look like when it's finished. It has a chamfer on the top as well. And I also have to do that with this end mill that I'm roughing out this larger pocket with a 5/16 end mill. I'm going to relieve the shank of it as well. And probably the very top of the shank of the finished tool here, I'm going to have to take 2 passes around this profile to get down to depth with this 1/8 inch end mill that I finish it with the 20 thousandths tip radius, because it only has a 1/2 inch cut length and this is a little bit more. But I'm going to do that after the chamfer is milled on here. We're going to, well, first it wants me to back up everything. So I guess I'll do that first. And then we're going to look for a suitable program that we can modify. I think I've already got a program made that I can reduce the shank of a tool. It's right here. This is the program I want, I think. Relieve shank of 1/8 inch end mill, 100 thousandths diameter, 850. Okay, let's open this. Now, looking at this on the simulation, this isn't going to be exactly what we want because I'm going to use a different grinding wheel and various things, but let's just look at this for right now. This is going to work for what I want to do, but I just have to modify it just a little bit here on the but first I'm going to save it as a different, I'm going to save it like that right now. I'm going to change the points on this manual grinding path. Well, first, I'm going to use a different grinding wheel here too. Let me change that first. Select, we're going to use this Naxo 1A1. Just the style of wheel that it is. Just simulate that just to make sure that no problem with that. See one problem already. Got to change the angle of the wheel. Here. 1A1, the other wheel had a 15-degree angle, so we've got to change this to, this machine won't, on a manual path, it won't let me put exactly 90 degrees in, 9999, so I'll just put it like that. For some reason, it won't let me do that. See, it moved the wheel to the other side. Let me see if I put 90.0001. See if it puts it back on the other side. Yeah, for some reason, that very small angular. See, then we don't need to move the wheel like that forward either. So let's change that a little bit on the points. First, let's see, where's this wheel grinding? The grinding position grinds on the inside of the wheel. So more or less, if we want this to go up 650, the wheel itself, let's see, measuring the wheel here. I mean, I could look at the data on the wheel. I guess I could do that, actually. It might be better. The width of the wheel is 461 thousandths. So we want to go 650 thousandths up. So 0.6, the dimension is on the back side of the wheel on this program, so 0.650 minus 0.461.5 for the wheel width. It's going to be 188.5. That's where we got to go with our tool grinding path. So 188.5 is what I said. So 188.5 here, and then we can change this to 0. And I think we can delete these. See what that looks like for the beginning. Might be all right like that. Let's see. We don't want to go to that small a diameter. Oops, see, it's got to go out again. So, got to have one more line. And we've got to go, see this, uh, 625, we want to go to a half of 110 thousandths, because this thing works on the radius. Divided by 2 is 55, 0.055. And we'll go back to relative and we'll change that to 0. And then we've got to go, we've got to move away 0.125 back with no revolutions. So this is the revolutions it's making. It's plunging down in, and it's making another revolution at the diameter. These are relative numbers, and these are absolute numbers here. I don't know if you can see those on this video, but so that, if I did everything right, let's see. We're just going to skim a little bit off. It should move out and away. Now this here is grinding into the flutes a little bit, but remember from the CAD or the simulation in the CAM software, I should say, we're only using the very tip of this tool anyway, so this doesn't matter. So we're going to grind back to here. This shows it extending further out of the collet. Let me change that too. So, excuse me, let's get changed here. We have it extending 750 thousandths out of the collet. Let's see what that looks like. This model, this machine simulation it doesn't show my collet chuck the way I built it on here. I haven't bothered to draw that any more precisely. Okay, but that's what we want to do right there. Just relieve that shank. Let's just see what we're going to take in time. It says the wheel's very close to the collet chuck. I know that. It says it's going to take 1 minute and 4 seconds to actually do it. It may take a little bit longer depending on what I override the feed rate to. So that's, and all we got to do is change this and tell it that that wheel packet's in the spindle, and we're ready pretty much to run it on the first end mill here. That's how easy this is. We're going to just probe the clamping length. We don't care about the flutes or anything in this case, and we're going to set that at 0. Send this to the, it's telling me again that the grinding wheel is very close to the collet chuck, which I knew it was going to be I stuck the end mill out 3/4 of an inch, 750, and I'm grinding a 650 deep, so it's 100 thousandths away, which I already knew that, so okay. Get back over here, see where our compensation, this wheel has got compensation value number 4 on it, which is going to be, let me redisplay those. Number 4 is set at 2,000, so we're going to set that at -5. Minus goes larger on this grinder, so if I set this on a minus value, it'll actually increase the diameter. I'm not really sure why that is, why they made it opposite of what you might think. And we'll grind it the first time this way and see what happens. I'm going to start it here, but you're not really going to see too much. I've got to close the door, and I don't know if I could reposition this a little bit so it's a little clearer, but I'll run it like this. And then I'll I don't know if you can see anything like that or not. Yeah, and I'll run it dry, and we'll see what happens on the second time. I'll just run it dry, and I'll put the camera in there. Right now, you're not gonna see too much. I'm gonna start without the coolant, so I make sure I'm in the right place here. Otherwise, I can't see anything. Okay. I want to change that rotation direction too. Let me see which way it's going to rotate. Right now we're going to move in, then it's going to move into the diameter. Okay. I'm going to turn the coolant on here. I don't know if you can see anything. Like I said, we're going to run this. Oh, wait a minute, I got a problem. Already I can see a problem. I didn't turn the coolant on that grinding wheel. As I change the wheel, it always undoes the coolant settings. Let me just, okay. Just want to make sure that I don't want to have this door open under any circumstances when the coolant's on. So you get showered with that oil, and believe me, you don't want to, that oil makes me break out too. For some reason it gives me a rash. So let's retouch the tool off. It's going to do that for every cycle because I got to change the tool, of course. So I'm going to run it in here with no coolant again and see what I'm doing, just like I did before. And now when I turn the coolant on, If I can do it here, it should come on, okay. But see, you won't see anything at all now. I'm gonna run it up. Feed rate. Then we'll measure the diameter and we'll offset it. Right now it's set at -5 thousandths on the radius. There's a radial offset when you put it on for this grinding wheel, and -5 actually moves it further away from the work or increases the diameter of the grinding. And like I say, don't ask me why that is. So I have no idea why they wouldn't make it the way you would normally think. Oh, what are we doing there? Turn this coolant off here. See, now I see an issue with my program. I don't know why we're rotating so much, coming back away. I think I got an angle on there. Let me look at the program and see what the deal is with that. Go back to Numroto here. I think I know. I think I've got an angle and holding the camera here. Maybe you can see this. I think I know what the problem is. See, I've got this 720 degrees here that I don't need. It was rotating back to the beginning position. It's kind of hard to see. You can watch this this little line here on the chuck, and you can kind of see it rotating. I didn't notice that when it was moving away, it was rotating that back. Okay, so that looks okay there now. Minimize that. We're going to have to resend this up to the machine. Go over to the machining and say like that. Manufacturing is going to give me that warning again. I'll say okay. And we should be ready. Now let's look here. You can see that the diameter, I don't want to grind this down. I'm trying to position the camera here. I don't want to grind this down any more than I have to here, but you can see it barely grazed the shank of the tool. So if I measure this, just get an idea of what diameter. Actually, I would like to hold this as big as possible and still have the clearance necessary. 121 thousandths. So let's take about 3 more thousandths off the radius of that. I think that'll get me where I want. So up here on offset number 4, right here, I'm going to change that. If I can get my cursor, mouse over there. I'm going to change that to -0.002 instead. We're going to rerun this. I could probably run that without coolant just for a couple of thousandths. So let's push cycle start here and see what happens. It's going to go over there and touch it off again, because I got it in the program to do that. I don't know if this is going to work. Hold on. The camera's in the way. It's going to hit the grinding wheel here. Position it like that. Might be good. Okay. Oop, still hitting the. Just barely relieving the shank of this tool. That's all we're doing. I say it's grinding a little bit into the flutes, but it's not going to be critical because we're not using that part of the tool anyway. Now notice it didn't rotate a whole bunch when it moved away either. So that's what we want. Let's see what we're ending up with for the diameter here. It kind of leaves all this crud on there when you don't run the coolant too. So that's about 115 thousandths, which should be enough for clearance. Unless the tool got awfully dull and it'd probably break by that point. So every time you make a change, you got to resend it up there. Because it's actually two different things. Here there's a program in the computer, and then it sends the program to the control, and and that's what the machine runs on. So you can actually do editing, if you will, on the program while it's running, if you want to make some changes. So I'm going to run this again with no coolant. Should be all right. You close the door, you might be able to hear me better when I talk. It should be all right because it's just taking very little off. Probably won't even be able to see it grinding at all, really, taking so little. Just want to move it down up the shank another 20 thousandths. I could probably grind it dry like this. It's only taking a very little off that shank, but I don't want to overheat the end mill shank, and because it can cause fractures or something in the carbide. Let's see one modification I can make to the program again too. I'm going to make one more modification. I'm going to increase the feed rate of it moving away. Doesn't need to go that slow. That's the actual time it takes to grind it. I don't know if you've ever done this thing on a manual. See, it leaves all that crud on there when you don't run the coolant. I don't know if you've ever done this kind of thing on a manual grinder, but this can take quite a bit more time than that. That's pretty fast. Probe it with no coolant again, just to Okay, I'm gonna turn the coolant on here. I'm gonna run it with the coolant. That's all there is to it, right there. So here we go. Here's 115 thousandths by, I can get it there, 650 thousandths long for the length. Should just clear just fine.